Hello everyone, welcome to the Mercury Virtual. Hope you are doing good. Today I am going to continue with the same module, that is the database design concepts, and the same chapter, that is chapter number 10. And so let's start with the previous class session. That is what we have covered in the last class, then moves to the today's topic, that is how to maintain the data or how to make the data organization possible. That is a data organization. So let's start with the previous class session. So in the last class we have started with the data dictionary storage. That is, what is the data dictionary storage, or what is data dictionary? In which we can store the data, in which we can put the data. That is a data dictionary. In that we have discussed about the data dictionary, how to maintain the data dictionary, what is the catalogs that is used in the data dictionary. Then what are the various integrity constraints that is available with data dictionary, so that we can use the data, so that we can maintain the data very well, so that there is no usage of the data, there is no pardon of the data, there is no lossage of the data. And one important concept is that there is no repudiation of the concept. That is, non-repudiation means there is no concept of the data that is available with the logic unit. That is the main concept. So data dictionary that defines the data catalogs, that defines the various profitable businesses. We can say the argument that we are given in the parenthesis that is available. So it defines the name of the relations, name of the attributes of each relation, domain and length of each relation that is available. Then name of the views that is available, that is viewed on the databases, that is used in the data dictionary. Then integrity constraints. In addition to this, there is a name of the index that is also available, and this is one of the example of the metadata, that is the data dictionary, like relation metadata, attribute metadata, user metadata, index metadata, and the view metadata. Then we are talking about the database buffer. That is, a database buffer means a storage of the various databases that is stored in a database buffer. Then how to manage the buffer? That is done by the buffer manager, that is the buffer management. Then we are talking about the buffer replacement policies. That is, what are the various replacement policies, or what is the buffer replacement policy that is available for the replacement. Then what is a pinned block that is used for the database system to be able to recover from the crashes. That is a pinned block. Then forced output of the block. That is what is the forced output, or how to maintain the forced output of the blocks. Then buffer replacement policies. That is, what is buffer replacement policies and how to use the buffer replacement policies, so that it can be used in a variety of tasks. It can be used for a variety of methods. And one of the main approach that is used is the LRU. That is the least recent used. That is a block replacement scheme. And there is MRU, that is the most recent use, that is also used for the database management. In addition to this, there is a system that is also available, that having a request, that is used for the buffer manager. Then there is also the summary of this chapter, that is what are the various concepts that is used in this chapter, that is reliability of the storage, and how to maintain the databases, how to take the databases, and how to gain the databases in a different concepts, right. One more concept that we have discussed, that is one important concept, that is how to make the database access possible. That is a sublet GSP that we have discussed in this chapter. Then sublet sessions, that is how to use the sublet sessions. Then sublet life cycle. Then this is the storage. Then the 10th chapter is storage media. That is a database access, the database dictionary. Then RAID we have discussed. Then rate levels, what are the rate level that is used in this one, and these are the various concepts of the rate level. Then this is a supported organization, that is a heap organization, file organization, sequential organization, that is available in this method. And then data dictionary storage that we have discussed already. And then database buffer, that is a buffer that contains the database or storage about the databases. Then summary we have discussed about this chapter, that is what is summary, what is the logic behind this summary. Then next is chapter number 11 that I'm going to start right now. That is chapter number 11 is indexing and the hashing. That is how to use the indexing and what is the meaning of the hashing. So index means simply referring the concept, or we can say the referring the concept that is used in the indexes. Or in simple terms, when we use the indexes, when we use the, we can say the margin, we can say the label or tag that is available in the notebook, or we can say the index is used for the interpretation for various concept, that is known as the indexing. And the hashing means also the same concept, that is using the hash table we are able to maintain the logic concepts, like. So let's start with this session, that is a indexing session. So indexing means how to use the index or how to maintain the databases with the proper indexes. So many queries that reference only a small portion of the records in a file. For example, a query that finds all the instructors in the physics department, that is how to find out or how many instructors are available in the physics department, that is the next concept. So that is how to maintain the query in that form, that is how to maintain or how to find out the instructors in a very small concept, in a very few concepts, that is also available in this chapter. Or another query is that find the total number of credits earned by the student with ID 2201, reference only a fraction of the student record. It is insufficient for the system to read every tuple of the instruction or the relation to check. In the same way, it is insufficient to read the entire relation or entire student relation just to find one tuple for the ID 3256. Ideally, the system should be able to locate these records directly. To allow these forms of access, we design additional structure that we associate with the files. That is, how to deal with the files, what are the various files that is deal with the files. So let's start with the basic concepts. What is the basic concept? First of all, what is the index? Index for a file in a database system works in much same as the index in the textbook. It is very similar to the index in the textbook. Like we are maintaining the index for referring to the chapter number 4, chapter number 8, like your book. Your book also contains the index. In the same way, there is an index that is available in the file in the database system that works in the same way as we do in the book, as we do in the notebooks. If we want to learn about a particular topic specified by the word or phrase, we can easily search, or we can search for a particular topic in the index at the back or the back of the book, right? In the same way, suppose if you want to find anything from the book, you want to find out either through the back, either through the beginning. And if I want to find any specific word, that is find by the ending of the book or the back of the book. Find the pages where it occurs and then read the pages to find the information for which we are looking. The words in the index are in sorted order, making it easy to find the word that we want. So words that is available in the index are available in the sorted order. That is, first of all, the A characters are available, then B, then C, then D. Moreover, the index is much smaller than the book, further reducing the efforts needed. That is, the database or the file index is very similar, and it is also very smaller than the index of the book. Database system indices plays a very important role as the book indices in the library. So database system indices also plays very important role as the book indices in the library, that is a book available in the library. For example, to retrieve a student record given an ID, if I give an ID, if I want to find any record or student record given in the ID, the database system would look up an index to find out which block the corresponding record exists. So if I want to find any ID, simply my target is to find the ID. So it will capture the image, it will capture the record, it will capture the corresponding record that resides, and then fetch the disk records. That means first of all, it captures the record, then fetch the disk file to get the appropriate student record. Keeping a sorted list of student IDs would not work very well on a large databases. So if I want to keep a sorted ID, or if I want to keep a sorting of the student ID, that will not work very easily. With a thousand of students, in the index would itself be very big. Further, even though keeping the index sorted reduces the search time, finding a student can still be rather time consuming. Instead, more sophisticated indexing techniques may be used. That is, more and more indexing techniques must be used. We shall discuss some of the techniques in this chapter. So there are various techniques of the indexing that is available. Now we discuss multiple indexing technique that is available in this topic. There are two types of, or there are two kinds of indices that is available. One is the order indices, one is the hash indices. So what is the order indices? That is based on the sorted ordering of the value. So if I want to sort the order of a value, if I want to sort anything that is done or that is represented by the indices, that is represented or that is sorted by using the concept of the values. It is based on the sorting order of the, or the sorted order of the values. That is, what is the sorting order, how to use the sorting order, that is known as the order indices. The next is the hash indices, that is based on the uniform distribution of the values across a range of buckets. So it is based on the uniform distribution of the value, that is a uniformly in a hash table it is uniformly assigned, it is uniformly designed to the various indices. The bucket to which a value is assigned is determined by a function that is known as the hash function. So it depends on the bucket in which the value will be assigned, that is available by the hash function. We shall consider several techniques for both order indexing and the hashing. So we consider both the several techniques or various several techniques that is available for the indexing, that is available for the hashing. No one technique is the best. Rather, each technique is suitable for various data application or database application. That is, no techniques we can say that is a very good or that is very suited for the application. No, it depends on the application to application. So it depends on the database application which technique will be used at what place. And each technique must be evaluated on the basis on the following these factors. So these are the various factors that is available to make the data possible or to make the done possible or to make the things possible, right? So what are the various methods, what are the various factors on which our techniques worked on? So first is the access types, that is what is the type of the access that are supported efficiently. So it depends on the type of access that are supported efficiently, and the access types can also include the finding the records with a specified attribute value and finding the records whose attribute value falls in the specified range. So it depends on the access type, what type of access that we are supporting. So the type of access that are supported efficiently, access type can include the finding the records with a specified attribute value, finding the records whose attribute values falls in the specified range. That is the access types. Then next is the access time, that is the time taken to find a particular data item or set of items using the technique in question. So that is these are the various criteria, these are the various factors that depends on the various techniques. So first is the access type, that is what is the type of access by which it can be referred. Then what is the access time, that is the time taken to find a particular things, that is the access time. Then insertion time, that is the time it takes to insert a new data item, that is how much time to take or how much time it takes to insert a new data item. That is the next concept, that is one of the important concept, as well as the time it take to update the index structure. So insertion time means the time that is available to update the insertion, that is available to insert. Then the next is the deletion time, that is the next one, the time it takes to delete a data item, that is the time taken that is used to delete a data item, that is the deletion time. And the time taken to insert item or update item, that is the insertion time. And this value includes the time it takes to find the value to be deleted, as well as the time it takes to update the index structure. Then there is a space override, the additional space that is occupied by the index structure, that is a space override, that is how much time it requires or how much time or how much additional space it is occupied by the index structure, provided that the amount of additional space is moderate, that is a space override, that is how much space is required or how much space occupied by the index structure. We often want to have more than one index for a file. For example, we may wish to search for a book by author or by subject or by title. That is, we may want that if a book will be searched, that will be searched either by the author name, either by the subject name, either by the title name. Now, an attribute or a set of attribute that is used to look up the records in a file, that is known as a search key. For example, if I get the search key by the author name, that key is known as a search key. That author name is the search key. And if I want to find the book by the title, that title is known as the search key. Note that the definition of the key differ from that used in the primary key, foreign key. That is not the key. This is the key that is used to find anything. That is the primary key, foreign key, super key. Now, this duplicate meaning for the key is established in practice. Now, next is that is the ordered indices. That is what is the main order in which the indices or the indexing can be maintained. That is the order indices. So to gain fast random access to records in a file, we can use the index structure. So whenever I want to find anything, whenever I want to gain anything, whenever I want to find the random access in the records in a file, we can use the index structure. That is the index structure that is used for the indexing part. Each index structure is associated with a particular search key. That is, every index structure is dealing with the associated with a particular search key that is available for the indices. Just like the index of a book or the library catalog, an ordered index stores the value of the search key in the sorted order. That is, every concept is available in the sorted order and associates with each search key the records that contains it. The records in an index file may themselves be stored in some sorted order, just as the books in a library that is stored, according to some attributes such as the Dewey Decimal Number. Files can have several indices, and whenever I want to arrange the records, whenever I want to find the file that contains a various record, that is sequentially ordered, that is order in a very sequence way, that is known as a clustering index. So clustering index is the index whose search key also defines the sequential order of the file. That is how to define the sequential order. That is a clustering. And clustering index is also known as the primary indices. The primary index also may appear to denote an item or index on the primary key. That is well, how to maintain the indices, or how to maintain the various how to maintain various indices that is available in the concepts. The search key of clustering index is often the primary key, although that is not necessary so. That is not mandatory to use the primary index, but this is the main concept, that is how to use the known concept key. Indices whose search key specifies an order, that is or other than the order from the sequential order of a file, that is known as the secondary indices or the non-clustering indices. The term clustered, non-clustered are often used in place of the clustering and the non-clustering. So either we can say the clustering, either we can say the non-clustering, either we can say the clustered, either we can say the non-clustered. There is no matter. Either we can use the ed, either we can use the ing. We assume that all the files are ordered sequentially on some search key. Such file with the clustering index on the search key are known as the index sequential file. So these are known as the index sequential file, with which we can denote the file with which we can access the file. They represents one of the oldest index schemes that is used in the database systems. They are designed for applications that require both sequential processing of the entire file and the random access to individual records. Now, next is the dense and the sparse indices. That is, what is the meaning of the dense indices? What is the meaning of the sparse indices? So, an index entry or the index record consists of a search key value and a pointer to find or to one or more record with that value as their search key. That is a search key, that is an index entry, or that is an index record that is used to maintain the records with that value that is used with the search key value. The pointer to a record consists of the identifier of a disk block. That is a pointer that is used, that is required with the block that is required with the record, that consists of the identifier of the disk block and an offset within the disk block to identify the record within the block. That is used to identify the block, that is used to identify the disk block. Now there are two types of ordered indices that we can use. So there are two types in which we can order the index, that is a dense index, and then is a sparse index. So there are two methods to use the indices that is available. So first is the dense index that is available, next is the sparse index. So in a dense index, there is an index that is containing or that contains, or an index entry appears for every search key value in the file. That is, every search key has got the attribute, has got the search key that is used in the file. In a dense indexing, in a dense clustering index, the index records control or contains a search key value and a pointer to the first data record with that search key value. The rest of the records with the same search key value will be stored or would be stored sequentially after the first record. So rest of the record that is used with the search key, that is used with the sequential access, that is used with the first record, because index is clustering one, that is one by one it is clustering, and again it is clustering day by day. So rest of the record that is used with the same clustering level, that is used with the clustering. And in a dense non-clustering index, the index must store a list of pointers to all the records with the same search key value or the search key concepts. Then next is the sparse index. So one is the dense index that we have studied, that is there is a clustering method, that is a search key that is used with the search methods. Then next is the sparse index, that is an index entry appears for only some of the search key, that is not every record, every search value in a file, that is not for every record there is a search file, no, but for the records for the entry index that appears that have a various search file, that is various search key values. Sparse indices can be used only if the relation is stored in a sorted order. So this is used only and only if the relation is stored in a sorted order that is available in the sparse index. Sparse indices can be used only if the relation is stored in the sorted of the search key, that is if the index is a non-clustering index, that is only available if the index is a non-clustering index. As is true in the dense indices, each entry index contains a search key value and a pointer to the first record with that search key, that is with every index it is available with the search key. Now to locate a record, we first find the index entry with the largest search key value that is less than or equals to the search key value for which we are looking. So we are looking for the largest search key that is available, that is less than or equals to the search key that is we are looking. We start at the record that is looking or that is pointed by that index value or that index entry. So we start with the new record, we start with the largest value that is available with the few records. Figure 11.2 and 11.3 shows dense and the sparse indices respectively for the instructor file. So there are two methods that is used. This is a dense index, this is a dense index that is available, and next is the sparse index, this is the sparse index. This is 10101, 32343, that is 76766. So using the dense index of figure 11.2, we follow the pointer that is directly to the desired record. Since ID is a primary key, there exists only one such record and the search is complete. If we are using the sparse index, we do not find any index entry for the 2222. So there is no sparse entry for the 2222 that is available. As another example, suppose that a search key value is not a primary key value, that is the search key value that is available is not a